All right, kiddos, coming back at you with part 2 of some proof tutorials here. I'm going to do number 6 and 9 on the ALEKS proof practice. So this would be a great thing to check out if you are having a hard time kind of grasping how to do proofs like this. So I'm going to go ahead and set my givens down first off here. I'm given S and T are parallel. So that means that any angles that involve lines S and T, any of those angle relationships that result from S and T being parallel, I can use those. I'm trying to prove R and T are parallel, okay? So I know that at the end of the proof, I'm going to have to use a converse reason to do that, okay? So if I'm trying to prove R and T are parallel, I may want to say something. Let's see, what do I know based on S and T being parallel? Okay, well, I know that quite a bit. I know 2 and 8 are alternate interior angles, or 1 and 7. Let's go with angles 2 and 8. Let's do angle 2 is congruent to angle 8, alternate interior angles. The lines are parallel. There we go. Okay. Now I also know that 2 and 6 are vertical angles, so I'm going to say angle 2 is congruent to angle 6, and those are vertical angles. Let's validate that. Okay. So now let's see, using transitive property, now I could say something about 8 and 6, couldn't I? I could say something about 8 and 6. So let's do that. Angle 6 is congruent to angle 8, and that's the transitive property of congruence. All right, now what could I say here? So I have 6 and 8. Those still involve S and T. How could I make the jump here to perhaps angle 4? Could I show angle 4 and 8? Yeah, because 4 is congruent to 6, and 6 is congruent to 8. So my next could be that 6 and 8. No, that 4 and 8, excuse me. So angle 4 congruent to angle 8. Now, let me explain why I went there next. So that's just the next natural step using the transitive property, but look now what I've gotten to show here. 4 and 8 are congruent. Well, if I'm looking at line R and line T, angles 4 and 8 are alternate interior angles. And according to step 6, I've now shown that those alternate interior angles are indeed congruent. And so now I could conclude that R is parallel to T, and the reason would be the converse of the alternate interior angles theorem. So let's find that. If alternate interior angles are congruent, then lines are parallel. There we go. Validate, and my proof is complete. All right. That's correct. Good. So as a strategy, I kind of started with what I was given. I used the fact that S and T were parallel, and I made some statements off of that. And eventually, I tried to work my way up to angles 4 and 5 or 3 and 6, some of the angles that involve line R, because I'm trying to show line R and T are parallel. So I just kind of followed the path that I started out here with based on the givens. Used some alternate interior angles, looked at some vertical angles, then just started using transitive property, and eventually landed on 4 and 8, which are a key set of angles to show that R and T are parallel lines. Okay, let's skip over to number 9. Okay, so here we have a few different angles here. Let's send these down to proof. Measure of 1 equals measure of 4, measure of 2 equals measure of 3. I'm trying to prove that measure of PQR equals the measure of TSR. So let's go ahead and use the angle addition postulate to define these measures of these angles. So measure of PQR, what does that equal? Measure of PQR is like the measure of 1 plus the measure of 2, right? So measure of 1 plus measure of 2, and the reason is angle addition. And I'm going to do the same thing for the measure of TSR. Measure of TSR equals angle 3 plus angle 4, right? Measure of 3 plus measure of 4, angle addition. Okay, So now look at what I've done here. I've set up steps 3 and 4 with measure of PQR and measure of TSR. And the reason I'm doing that is because now if I can figure out how to get the right side of this equation in step 3 to look the same as the right side of the equation in step 4, then I would be able to conclude that the measure of PQR equals the measure of TSR, right? I'm just trying to show that they equal the same thing. But look at what I'm given here in steps 1 and 2. I'm given that 4 and 1 are equal, and I'm given that 2 and 3 are equal. So what I can literally do is I can take 1 and substitute it with 4 here, right? So I can put a 4 right here. And I can take this 2 and substitute it with a 3. Can I? Let's go ahead and do that substitution, and then the right side of those equations are going to be the same. So I'm going to redefine the measure of PQR. Now, could I just redefine the measure of TSR instead and do the same thing that way? Sure. No matter how you want to do it, you got to redefine one of these angles here. So I'm going to go ahead and redefine PQR. I'm going to redefine it as the measure of 3 plus the measure of 4, which it is after you do the substitution. So substitution, there it is, validate. Okay, so now look at this. This right here is the same as this right here. So therefore, these have to be the same, right? So now I can say measure of TSR equals, remember with measures, I'm using equality, not congruence. Measure of TSR equals measure of PQR. And that was, again, substitution. Check it. And there it is. Correct. Okay. All right. So now, between the first video, I gave 3 examples, and in this video, I gave 2 more. Okay. So hopefully, between all that assistance with the videos, that clears things up a little bit. Feel free to stop by during Study Center or send me an email if you need anything. Okay. All right, everybody. Thanks. Be well. Talk to you soon.